Okay, so we should probably take a look at the agenda so we know what we're doing today, right? So you had homework. How many of you did it? Okay, I'm going to give you some extra time to do it because we are not going to have other homework until Friday. Okay, so go ahead and do that tonight if you haven't done it already. Those problems are very important to do, but we won't talk about it until we get into class on Friday. So do it tonight, do it tomorrow night. So we first have to talk about some similar figures and ratios that have to do with similar figures. Yesterday we kind of recalled what we know about dilations and similar figures. We're going to need to, when I pause and when we pass out papers, I'm going to have you get out those papers from yesterday because those will be helpful, the field guide and the one dilation that we looked at. But then once we talk about those ratios, we're going to talk in groups about the ratios that you find when you do similar triangles and what we can figure out from those ratios and if we see any patterns. And like I mentioned, it leads into trigonometric ratios, so we're leading into something that's extremely helpful for this year and in pre-calculus and actually helps you to solve some real-world problems that you actually might do on your own someday. So we'll talk about that. So what we're trying to answer is how can we find the measures of sides and angles in a right triangle? So if we're only given one or two pieces of information, how can we then find all the other pieces of information? All right, so why don't you get out those two pieces of paper, and then Austin's going to pass out the first handout that we're going to use. Once you get the handout, if you can please just read the top part. You don't have to do anything yet, but just read the top part, get a sense for what's being told to you on the paper. The field guide. This is the most important one. And then this one right here, we just kind of examined like these two are parallel lines.
Oh, do you do that?
Things like that. Maybe. Were you not in class yesterday?
I don't remember doing that. Well, I was trying to figure out that just after.
Oh, gotcha. Okay. So, but I'm not sure you'll be lost because you'll be working with your group. So,
Should I
It'd be
grab
okay.
that paper?
no, I don't think so. You'll be good. Okay, so if you could wrap up your conversations, please. Sorry, Carissa, you won't have to look this way for long, but if you want to turn for now, we are going to work on the document camera. Okay, and bring your conversations to a close, please. Okay, so let's take a look. So we have two figures here. We have quadrilateral ABCD and its image AB, A, B prime, C prime, D prime. And so that's what that says right here, just in case you didn't see it. We're also given some lengths. Now, normally I would put the lengths right on the picture. I put them over to the side for a reason. So we'll be used to, when we do the investigation, looking at measurements separate from the picture. So I'm going to help you do number 1 and the beginning of number 2, 2A, I think. And then I'm going to have you try B and C based on what we did in the first part, and then we'll talk about it. Okay, so let's first take a look at the fact that we're trying to find the scale factor in number 1, and it says use side AB in its image. Okay, so we have side length AB here. And then we have its image, AB prime. So anyone want to take a guess as to how we use those two numbers to find the scale factor? Do you remember? And it's okay if you're wrong. We just need somebody to try, right? Mason. Thank you. Carissa, you're up front. Try it.
It's going to be a ratio.
Okay, so what do you mean by a ratio? What should I do?
Well, AB's, like yesterday we did it where it was, the ratio was 2 to 1
Okay, should I put them, how should I put them on?
in the front.
In a fraction? Okay. So what would you do with the two numbers?
We do the 3 over the 2.
So 3 over 2. So let me just write in front of it. So you think that AB prime goes over AB. Okay, how many of you think that's the way we should do it? How many of you think it should be upside down? How many of you think something else? All right. Tyler, can you take a stab at why you think it's 3 over 2? So let me put this in a decimal form. So scale factor of 1.5.
It's like, I don't know, it's over a fraction, so 3 over 2 is the same as 1.5.
Right, so how do you know that it's 1.5 instead of 2/3? Here's my original. There's my image.
The image is bigger than the original.
Right. And it looks like it's not quite 2 times the length, somewhere between 1 and 2. So 1.5 probably makes sense, right? Okay, so can we take this as the scale factor? Could we just use 2 sides if they're similar figures? Does that sound okay? You guys are scared to talk. All right, so let's use that scale factor to find the length of B prime C prime. So notice that we had a ratio already. So let's think about it this way. The ratio of the image to the original is going to be the same as the ratio of the image to the original. So the image of B prime C prime, that's B prime C prime. And what's the original side for that one? Just BC, right? Okay, so we already knew that B prime over AB is, should we use 3/2 or 1.5? Doesn't really matter, we just have to pick.
1.5.
Let's use 1.5 then. But I want you to keep in mind today that you can convert from fraction to decimal whenever it's convenient for you. Okay, they mean the same thing. So now we know, do we know B prime C prime? We're trying to find that one, so we're just going to write that down. And then over BC, 2.83. So now, Sydney, if you could help me get B prime C prime by itself. You have to do something to both sides, right? And I'm undoing division. Multiply what? Do I need to do it somewhere else? Right. Okay, so if you could all grab your calculators. Because on my right-hand side, my 2.83 over 2.83 simplifies to 1. So I'm left with B prime C prime. And then what's my left-hand side going to equal? So 4.25 centimeters. So I've used the concept of this ratio is going to be equal to this ratio to help me find my missing side length. Okay, so I've used, we know this ratio, image over original, is going to be equal to image over original because similar figures are in a constant ratio, the side lengths are. Right, so remember that from yesterday, that's on your field guide. Our side lengths are in a constant ratio to each other. So now I want you to try in your groups, and you can talk to each other about it if you need to. Try and find the length of C prime D prime, and the length of DA. See what you can do. Revised. You guys can talk to each other if you want to. in there. But now, did you put things in the same order?
Yeah, I think I did it wrong.
Well, you're looking for C prime, D prime, right? So where is that in this equation?
Right. Oh, I meant to put.
Oh, gotcha, okay. So you just forgot the primes, okay. So 1.5 is image over original, right? Because that's what we set up here. And then is this image over original?
Yeah.
Okay, so now what would you do?
1.5 times 2.16. Right?
Well, yeah, I'd like you to try and do it algebraically because you want to show that it's going to simplify on the right-hand side. So dot 3 point, yeah, just like I did on the board.
Times 3.16.
Mm-hmm.
How does that break down?
Because you do AB prime over AB equals DA over D prime A.
You okay?
Yes, 73 times each side by 4.6.
Wait, that's D
Austin,
prime.
I have a question for you. So you did image over original. Do you have image over original over here?
No, but this is different than, or would you flip the
If you're going to flip one, you need to flip the other. Does that make sense? Because you want that constant scale factor and you don't want to turn it into 2/3. There you go.
Oh, so you don't want to turn it into 2/3?
Well, you wanted DA on the top, right? And why did you want DA on the top?
Because that's the thing that you're trying to find.
Right, so it'd make it more convenient if we could put it on the top so we don't have to do so much rearranging. So then you would flip-flop instead of doing it this way. You'd put the numbers upside down.
So then it's 2/3.
Mm-hmm.
Okay.
And we're not changing which one's the original and the image, but we're changing just which way we represent the ratio. And then you guys will want to make sure that your numbers make sense, right? That they look like they're going to be that length. How are we doing?
Okay. For this last one, I heard you talking to the other table about flipping.
Mm-hmm.
Do we need to? I thought it was always the.
So when we worked with dilations, we were really concerned about original versus image. In this case, we're really just trying to solve for unknown side lengths. So I don't care which way I put the proportion as long as both fractions are the same arrangement. Does that make sense? So either image over original or original over image.
Okay.
When we want to talk about original versus image, yes, we want to keep it this way.
Okay.
This one is 1.5 times bigger than this one. But when we find side lengths, because even if you'd set it up the other way, or I'm sorry, you set it up this way,
Yeah.
you're going to want to flip it over because DA is on the bottom,
Okay.
right?
So you would flip it over in that.
Eventually you would have to flip it over anyway, or you would have to multiply on both sides by DA.
Okay. So
To get DA on the top. It's easier, right? Because then you don't have to get it in the numerator.
So we can like just start it there.
Yeah.
It wouldn't give you a different value in the end.
As long as you do your algebraic steps correctly, you will get the right answer regardless of where DA starts.
Okay. This is easy. Should I just turn this in tomorrow? Nice.
That'd be awesome. Yeah, if you don't mind. And if you can't do all of it, it's okay. It's not graded. It's, and maybe right at the top absent so that I know yours wasn't corrected. How are we doing?
Okay.
Nicole's kind of helped put us through it.
What's that?
I think I said Nicole. Yeah,
Would one of you be willing to tell me one of them how you did it? I'll write it down how you did it. You sure? Okay. All right, which one do you want to do, B or C? Okay. Yes, sir.
So I'm not really understanding this because you're trying to find dA, right?
Right?
So how can D prime and then A be 4.7 and they got 7.11? So they're saying this is bigger than this.
So this is confusing, right? It shouldn't be that big because it should be smaller, right? Now, notice that you put image over original here, right? So dA is on the bottom, and you're trying to solve for it. So algebraically, if it's on the bottom, I got to get it to the top to be able to solve for it. Like if you guys just multiplied, that equals 1 over dA. Does that make sense? So what I would suggest is flip the whole thing over, like flip both ratios over. So instead of 3/2, 2/3. And now dA is on the top. The unknown is on the top. Does that make sense? Okay. Hey, would one of you be willing to talk us through C, like the reasoning that you were doing and how you set it up the way you did?
No, I don't even know what I did. I asked him for help.
Well, if you volunteer this time, maybe you won't have to talk as many times.
Or if you just not talk at all, that's
Well-
cool too.
Well, because I was listening to what you were saying, and it made sense, right? And not everyone in the class is seeing that. Every other day you're happy to talk.
Yeah, I know, but I just,
Remember, no one you know is going to see the video.
I think you should get like money or something.
Right, right, I'm going to pay you. No, I don't think so.
Come on, Mr.
I mean, do I have to like stand up?
No, you just have to tell me from your seat what to write down, and maybe why. Maybe Hannah can help you with the why.
Yeah, I guess I.
All right, thanks. Could you raise your hand if you need more time? Do you just need to figure out that last one? Yeah. Okay, I'll give you another minute or so. I'll give you another minute or so. They didn't come to your table yet. How are we doing?
We all
Yeah.
got the same.
Did they seem like they made sense?
Yeah.
And then what did you do with this one here?
We divided it because this is like bigger than this one. Were we supposed to divide it?
So talk me through what you were thinking.
Well, dA, but that's like the length of dA. But
Uh-huh.
we divided it because
Instead of
A-
multiply?
yeah.
Okay.
Because we thought we needed to like make it like smaller. Were we supposed to multiply?
Okay, so I think if I'm remembering how you guys did things in 7th grade, that would have been like if you're going smaller, you need to divide. If you're going bigger, you need to multiply. Okay, you are correct. What I want you to think about though is you set up image over original and then original over image.
Oh, I need to
So-
switch this one.
Yeah, and if you did that, you wouldn't have to do something weird here.
Okay.
You know, like I get like why in 7th grade we want to do things that way because we need it to be a little bit more concrete. But now that we have more algebraic skills, we want to try and use those. You know, does that make sense?
Yeah.
Because if you flip-flop this one, dA is on the top, and you can still do your multiply on both sides by the number underneath.
Okay. Are we so this is
It's a correct answer,
Oh, it
and it's actually a correct method. It's just hard to follow keeping both sides equal. You know what I mean? Because you didn't actually perform an operation to both sides that makes sense for the proportion that you set up.
okay?
That makes sense.
We get marked down if you did it that way.
No, a correct way is a correct way. I'm just going to always encourage you to do what's going to help you going forward in you know in your math classes, and we get a little bit more symbolic and make sure that we're showing our steps balancing equations, right? One side has to equal the other side. Good? Okay. Okay, if you could wrap up your conversations. All right, so I have a couple of volunteers. Well, I asked them, but a couple of people who agreed to tell us how they did these two problems. You may or may not have done it the same way, but we'll talk through how they did it and why that might be a way that you want to use or not. So Nicole, could you help us with V?
So I did image over original, which is
So you put C prime, D prime over, okay?
It'd be 1.5.
So equals 1.5. And can you just explain why you put image over original instead of original over image? That's why how I did it up here. Right, so 1.5 is image over original. Okay, and if I did it the other way, it'd be 2/3. Okay, all right?
So then 1.5 equals C prime D prime divided by 8.16.
Oh, gotcha. Okay, so let me see if I can represent this as the same equation. So you put CD as 3.16, and then equals 1.5, and then you multiply it on both sides, which ends up giving you 1.5 times 3.16, right? Okay. So what did you get for C prime D prime then?
4.74 centimeters.
And somebody else at your table, why does that number make sense to you that you did it right? I don't care who. 4.74 makes sense because? And we were looking for the image, which we know is going to be bigger, right? Okay. So please always do that sense check. Is this number that I'm getting making sense to me? Okay, anyone do it differently? Okay. All right. C. Austin, could you help us out?
I did original figure over image.
So you flip-flop them.
Yes, because you're trying to find DA and not D prime A.
Okay, so you put dA on the top so that it makes it easier to solve.
Yeah.
Okay, so dA over D prime A prime equals, and then what'd you do for the other side?
It puts the ratio, so it's 2/3, which equals 0.67. And then
Oh, you used 0.67, sorry. Okay,
and then that equals DA over 4.74.
because that's the length of D prime A prime from up top.
Multiply each side by 4.74.
To get dA by itself. Sorry, so dA is 3.2 centimeters. And Hannah, could you help us with why that number made sense instead of some other groups got like 7 centimeters?
Yeah, because depending on like what you set the ratio to, if you were to do the A over B prime or AB prime over AB,
Uh-huh.
that could like mess up what you would use to multiply.
Right, if we're gonna flip this ratio over, we have to flip the other one over too and make it 2 over 3. Good. And then why is 3.2 a good number compared to 4.75? I started out with this length is 4.75.
Oh, because it's smaller.
Right. So 3.2 is smaller than 4.75. Seems like it's headed in the right direction. Awesome. Okay. Questions about what we've done? All right, now we can actually do the investigation. When you get the investigation, I'm going to take you through a couple of pointers. Austin and I are going to pass it out to you. And then you will get started in your groups, and the rest of the time will be spent talking with your group. If you need to, yeah. Can you wait for instructions first? Yep, I did. Are we good? Thank you. Oh, there's 5 of you. Sorry. Yes, ma'am.
Why did she get like 3.2 and we got 3.6?
They use 0.67 instead of 1.5, and so the rounding might, well, and if you round 3.16, aren't you going to get 3.2? So maybe they just rounded it more. Okay, if you could wrap up your conversations, please. Christian, can you wait? Hannah, can you wait for instructions? Okay. Christian, can you wait for instructions? Okay. Okay. So let's take a quick look at what the investigation is asking you to do. So it says that you're going to take and plot 2 points, one on the x-axis and one on the y-axis. Notice on the right-hand side of the graph, in number 1, it says group 1, 2, 3, 4. There are 4 people at your table. One of you be group 1, one be group 2, one be group 3, one be group 4. If you don't have 4 people, so this table over here, be groups 1, 2, and 3, skip 4. Okay? You guys have 2 people do the same one. Okay? Actually, why don't you have 2 people do 4, because they won't have a 4. Does that sound good? Okay. So you're going to follow the directions. You are plotting points and then drawing line segments. And then those line segments make right triangles, because the line segment will join with the origin, and you'll have a right triangle. It'll make more sense once you start doing it. Each of you at your table is going to start with different points. On the other hand, you can kind of help each other as you want to or need to on, am I doing it right? Right? Because you all should be going for the same outcomes, just using different points. So let's flip the piece of paper over. Notice there's a couple of questions down at the bottom that you want to try and answer. You should try and answer those questions together, if possible. And then if you look at number 5, it says start measuring. So remember, I asked you to get a ruler. Make sure you know which side is centimeters and which side is inches. We're going to measure in centimeters to the nearest tenth of a centimeter. So those are the fine increments, or the fine marks on your ruler. We're going to write our measurements in the table. Please be as accurate as possible. Take your time, because if the measurements are off, it will really mess up your ability to do the rest of the work. And then the rest of the table, it should be, you should be able to figure out what it's asking for, but I've given you a model of how I'd like you to fill in those last 3 columns. So please try and follow that model to help yourself understand what it is that you're doing, and also to help you understand that ratios as fractions and as decimals are the same thing. Number 6, as you do that one, you should be able to talk together about what you're seeing. Number 7 is for each individual person to work on. You're going to have different numbers, so the problem that you're doing there will be individual. But again, you can kind of help each other with the setup. And then we'll work our way through to number 10. Depending on how things go, remember I haven't done this lesson before. I might stop us before we get to number 10 altogether. I might have the groups go through number 10, and then we'll talk about everything when we're all done. The only other thing I'd like you to do is to help us with understanding what relationships and patterns we're seeing. If you notice, there are 4 posters around the room, 1 for each group. Once you come up with your ratios, so these would be the last 3 columns in number 5, I'd like you to write those 9 numbers on your poster. So that's why you have a marker, right? So make sure your marker works, of course. I have extra ones if yours is not working. But you're going to go to that poster, and I'm trying to decide whether I'm going to leave that poster for all 4 classes or if I'm going to just have your class. So write things big enough so you could see it from the other side of the room, but don't write it so huge that we couldn't get other numbers on there. Questions about how to get started? Okay, of course you can ask questions as we go. And those of you who have been waiting for me to stop talking so you can go use the restroom, if you want to go do that, you can.
I'll do it.
I'll do number 1. Alright, you and me do 4. Me and Ryan do 4.
Yeah, me and Kim got 4, so pick 1, 2, 3.
Hopefully we don't have too many people though.
No, I think just Christian.
Yeah. Oh, I just saw one. That's okay. That's fine. Yeah. Did we get a group yet?
2. I'm group 2.
No, each of you is different group.
Oh, okay.
So one of you's 1, one of you's 2, one of you's 3, one of you's 4.
Yeah, I got 2.
Did we pick groups yet? Yeah? You know which group you are?
Yeah.
Okay. Yes, ma'am.
What's the origin? Unless I did this wrong. Which
0,
I don't
comma
get.
0,
Right.
right there.
Makes a lot of sense now.
Yeah, I can answer those questions
that's
for
the-
sure.
that's the-
Yep, so that's your triangle,
Oh,
right.
sweet.
Makes a triangle with the axes.
I make it a try.
You guys each picked a group, right?
Mm-hmm.
Excellent.
How could you draw parallel lines? It says label the origin and convert them to zero would be origin.
Mm-hmm. Yep, point A is 0, comma 0. Can you cut my mic for a second? Yes, ma'am.
So for number 2 would be just like keep going.
So how do you know where a parallel line would go, like how to draw it?
Parallel to the line.
And how would you know for sure that it's parallel?
I don't know how to explain it. Like I just know that it would be there.
So I think you're saying visually,
Yeah.
right? What's another way that we can make sure that we have them parallel and they're not slightly off? Think about what we did with that take-home assessment. How did we figure out that lines were parallel then? Do you guys remember? Has to do with what you know about algebra.
Well, I didn't do that great last year, so.
Yeah, but you've done it this year. How do you know if two lines are parallel to each other? Like, how can you confirm that they are? They should have the same something.
Oh, the same like distance of, like the difference in the numbers.
Difference apart.
Well, that's length, I think. But there was another way that we used those difference in the numbers. Change in y over change in x, rise over run, slope. Does that make sense?
Yeah.
So if you know what the slope is of your original line, parallel line should have
Same slope.
same slope. Exactly. So like for yours, you got to figure out, well, what kind of a slope do I have, so that when you go to draw a line that's parallel, you'll know for sure that you drew it exactly where it should be. Does that make sense? And don't worry about getting right on an actual like set of numbers. Like you might be on a fraction of a number, that's just fine. because we're measuring the length of the line segment in centimeters, not in graph units.
Okay.
So
I'm
for
confused.
2 for the parallel lines,
So I want you to think back to the last time we did something with a coordinate plane. We did that take-home assessment, and we had to come up with, well, what are the different properties of these quadrilaterals? And one thing we did was, are these two lines parallel to each other? What did we use to confirm if two lines were parallel? Like if they were already drawn?
Can I look at that?
If you want to, yeah, go ahead. You can look at
they
it.
have to be like doubled or something, or at least like within a fraction of it. I'm not sure.
And then like x1.
Like they're supposed to be like around the same. Say this is like 10, then this goes up to 16. Maybe a parallel line.
Might have to look for your notes, because I think I have yours.
Yeah, I think you do.
Anyone
I
else have
there
their,
was no-
oh, the notes one?
just like
Yeah. So what did we compare to know that they're parallel?
so to know that they were parallel, how would you know that? So it's part C. So we did the rise over we found the slope.
So Christian, does that make sense?
A little bit.
So how would you confirm if those are actually parallel to each other? They would have the same what? Say that word again.
Oh, slope. So you have to, how can you draw lines parallel to BC? So you have to figure out the slope.
Could you like also double this number and double that and still be parallel?
Well, so, but calculating the slope would help you to verify whether your conjecture is going to work or not. You know what I mean? Like you have to have a way to verify, and that's the way that we can verify for sure.
Rise. This is how I would rise is the y. What's that one equation? It's like y1 plus y2 or something.
Distance?
No, to find the rise over run.
Oh,
Like
you
from
just take the
two-
difference in the y's over the difference in the x's.
So you subtract them.
Y2 minus y1 over x2 minus x1. You can look at your notes if you need to.
Okay, I think I know what you mean. So it's y then x.
Y on top,
Yeah,
x on the bottom. The change in y over the change in x.
so like that follows.
Subscript, not this is to the first power, to the second power. You want to put the 1 and the 2 down there.
Where? Oh. Wait, what? Oh. Okay.
Oops, that's an x. There you go.
Thank you.
You're welcome. Well, what do you think? So slope we read from left to right. So are we going uphill or downhill? Is your line going uphill or downhill? So it should be positive or negative, right? Okay. And so does it seem to you like for every unit you move this way that you're going down 2.3 units?
Looks like I'm going
I just like the four sides.
or wait,
Rise
going
over
down.
the two.
I don't think we have four sides now. I think we only have.
Did you get 7?
Okay, yeah, but I'm just.
You said the difference.
Okay. So basically,
Well, 3 is an x value. 10 is a y value.
what side is it? Right.
You could just do from here to here, right? The change in the y's is down 10. There you go. But so this says a little bit more than 3. As you go 1 this way, you're going down a little bit more than 3. You go down 1 again, you're a little bit more than 3. Does that seem like it's making sense?
Yeah.
Okay, positive or negative?
So then is that
So that gives you the slope of this line, right? So now how can you draw lines parallel to that line?
the slope stays the same?
Mm-hmm, good.
So just write that.
Found 0.6.
Well, that's what this question is asking, and then it's going to ask you to actually draw them. And you can kind of talk to your group about how that works too. Yes, ma'am.
Are these right? Because I don't want to like move on if they're
So let's see here, by drawing a line from point B to point C. So how can you draw lines parallel to BC?
Oh, you just, well, you would have to go down 30 and then over 2.
Mason, can you work with your group, please? What's that?
You would just have to go down 3 and then over 2, right?
So how do you know that these lines are parallel?
So
They all look
distance from-
parallel?
Yeah, they're like equal distance from each other.
You want to ask your teammates what they said while I listen?
They're like, to make sure they're parallel, they're just like equal distance from each other.
I said that they have the same slope as point B and C.
Does that make sense?
Yeah, but like if is like, is it okay to do like all equal distance from each other, or do they need to be-
Well, what do you mean by equal distance?
like they're all down 3 and over 2?
What's the slope of your original line?
10. Like it's just, I don't.
So you have some notes on how to calculate slope, right?
Yeah, are they like in?
Mason, what'd you say for number 2? Shh. Try not to be loud. Say that again. Okay. So did you calculate your slope to figure out?
No, I just went over.
Okay. You might want to take a look at those directions in number 3. You're trying to get all the way to the x-axis. Does that make sense?
Are you on this we took notes or like on the sheet?
No, well, the last time I can think of that we really used slope to figure out if lines were parallel was that take-home assessment,
Oh yeah.
and you know the papers that led up to that.
So Mrs. is this one in?
Well, how would you know if you're right?
Seeing if they're finding their slope.
Mm-hmm. Yep, so see if you can figure out what the slopes of your lines are. And when you calculate slope, and it doesn't matter to me if you try and do it with numbers or with, you know, just using slope triangles, because you can use a slope triangle too, right? But trying to figure out for yourself rather than asking. Well, it's a very important concept to grasp for yourself to be able to understand the rest of what we're doing. So we can take the time to figure it out. Yes, ma'am.
Okay, so I'm a little bit lost here. So it says, to find the measurements for A, D, E, and everything, but that, because it's A and then I have B and D, so I don't know how that would work.
So you want to think about, you have a triangle, A, B, C here, right? And you could even highlight them if you wanted to. And you have A, G, E here, and you have A, F, D.
It says do D and F, but it says find the measurements of A, D, E, and that's not a triangle.
Oh, so flip-flop.
But it says do D and F as a triangle. Says that one.
D and F should both be on the same axis. D and F should be here. So flip-flop this one, and I think that one. I think so. Let's try that. I'll wait with you and make sure. How'd you guys figure out if your lines are really parallel? What'd you do?
Who dilated it?
Oh, so how did you figure out that you actually had your line segment parallel?
Well, I came up with like I said, more line segments parallel to BC. so I knew that DC was like 1 if you were like to dial in. And then
Okay.
1.5 if you multiplied one of the points.
So you figured out a scale factor you wanted to use,
Yeah.
and then dilated these 2 points?
Yeah.
Okay. Did you do it the same way? So did that match your triangles up? Excellent. Good. Yay. How are we doing?
I'm stuck on
Oh, thank you. So number 7. So did you notice how, oops, so you actually want to calculate this as values to the nearest thousandth. So do that dividing and look at the ratio here. And then you want to put the actual side lengths first, like the actual names of the sides first.
Okay.
So you can see down the, you know what I mean?
Okay.
So you have a little bit more to do in that table.
Do you want us to put it like back into a, or no?
To the nearest thousandth, so 7, 1, 1. Guess what, everyone? It's almost the end of the hour. If you would like to pack up, you may. If you could leave your rulers just on the tables and your markers. I think that's the easiest. You cut my mic and